Dzień dobry Państwu. Ponieważ nasze seminarium jest transmitowane, więc Państwo pozwolą, że ja się przedstawię też tym, którzy nas słuchają, a może mnie nie znają. Ja się nazywam Tadeusz Burczyński. Jestem kierownikiem UNESCO Katedry, która jest organizatorem tego seminarium. Witam wszystkich Państwa zebranych tutaj w auli oraz osoby, które oglądają nas właśnie zdalnie. Proszę Państwa, jest to pierwsze inauguracyjne UNESCO seminar organizowane przez Katedrę UNESCO na temat Ethical Governance of Artificial Intelligence, która została powołana w naszym instytucie, w Instytucie Podstawowych Problemów Techniki na przełomie czerwca i lipca na podstawie decyzji sekretarza, pani sekretarz generalnej UNESCO. Wykład pod tytułem Artificial Intelligence and the Future Science jest frapującym tytułem, bo możemy oczekiwać tutaj wiele ciekawych rzeczy i wygłosi go, i chciałem tu przedstawić, pana profesora Włodzisława Ducha z Uniwersytetu Mikołaja Kopernika, kierownika Katedry Informatyki Stosowanej. Już nie, ale wiem, że na pewno byłego wiceministra nauki i szkolnictwa wyższego. Wiele osób mogło także w tej korzystać z kontaktu z panem profesorem. Witam cię, Włodku, serdecznie w naszym instytucie i dziękujemy, że przyjąłeś nasze zaproszenie. Czujemy się zaszczyceni, że znalazłeś czas i przyjechałeś do nas. Proszę Państwa, tym seminarium otwieramy comiesięczne, przynajmniej na razie, może będzie częściej, spotkania na temat sztucznej inteligencji, które odbywać się będą nie w poniedziałki, tak jak dzisiaj jako pierwsze, ale będą odbywały się w czwartki o podobnej godzinie, o 11 przed południem. Good morning. My name is Tadeusz Burczyński. I'm a chairholder of a UNESCO chair. I greet all of you present in the auditorium and the people who watch us via broadcast. This is a first inauguration UNESCO Chair seminar organized by UNESCO Chair on Ethical Governance of Artificial Intelligence, which was established at our institute at the turn of June and July in this year on the basis of a decision of the UNESCO Secretary General. The lecture under the intriguing title Artificial Intelligence of a Future Science will be delivered by eminent scientists, Professor Włodzisław Duch from the Mikołaj Kopernik University of Toruń. We welcome all people, and especially Professor Duch. And thank you, Professor Duch, for your accepting our invitation. This seminar will open monthly, for now, meetings on the artificial intelligence, which will take place on Thursday at the 11 a.m. Professor Duch, the floor is yours.
Thank you very much. And I'm very honored to start this prestigious series of lectures. I understand that it will be better to talk in English, and the slides are in English. And the idea that I usually pursue is that if you just write in any search engine my full name, you find my webpage, and on my webpage you find these slides. And these slides have lots of links that will allow you to find interesting things, because there is so much going on that I'm not really able to tell you much. And I will tell you, actually, I've thrown more than 100 slides from my initial presentation, because we have limited time. And I'll talk about a few thoughts on AI in general, and superintelligence and exponential growth of AI, and then AI for science, the autonomous agentic AI science factor is coming. And then I'll also mention the ethical side in the last few slides. So we've really opened the Pandora's box, and we don't know if we should be more afraid that AI will turn against us. Many people ask this question all the time, or that we turn against AI and then others will enslave us because they are going to pursue vigorously AI. That includes also the Chinese and American people. So if you look at the archive CSAI, that's one place where you find recent information about AI. Every week we have from 150 to 300 papers a day. There are weeks like 1,500 papers or more. So it's impossible to make any overview. NeuroNIPS, which was this year, received 15,000 papers, of which more than 5,000 were accepted. So you can imagine that this is now such a big field that we just cannot really handle that. And I must say, in '94, I wrote the first paper with my colleague from Munich on neural networks as tools to solve problems in physics and chemistry. Now, this is the topic number one, how we use AI for development of science. And to make your life easier also, I'm collecting mostly interesting things for myself, but this is about AI news, robotics, computing tools, machine learning, and lots of other things. Including the brain stuff and quantum computing, etc., on my Flipboard. If you haven't used the Flipboard, you can click here and you'll get to the, Flipboard, which just is a kind of aggregator where you can put anything that you find in the web. You just drop it in there, and then you have links to videos, to web papers, or to archive papers and other things like that. So you see that I have wide interest, lots of different subjects, and thousands of these Flipboards, because there is so much noise now in the internet that if you just look at any kind of resources, you find that 90% of them are really junk. So what is happening right now? The EU finally is waking up. In in 2018, they had a communication from the EU Commission to the Parliament, and they promised about 20 billion euro per year to develop AI. Nothing like that happened, actually. But now they say, okay, we have the new project called RISE, paving the way to resource for AI science in Europe. And they just found 108 million of euros, comparing with billions that Americans and Chinese are spending. That's just peanuts, but okay. RISE, it will be, as a kind of a virtual European institute. We've been proposing in Poland a virtual institute for AI since 2018, actually, with no success, actually. So this should be ethical, explainable, transparent, accountable, reliable, safe, human-centric, and aligned with human rights and social values. Well, very nice slogans, but can we really do that? That's the big question. But it seems that lots of people are now concerned about relating AI models because of ethical problems, accuracy, security, lack of transparency, etc. And so people lack guidance, and Europe is ahead of other countries in just formulating these kind of guidance. The European Group of Ethics in Science and New Technologies is going to evaluate this program. Well, we'll see how that will work. And our government also has a web page called Nauka, or AI dla nauki. So they all also talk about science for developing AI and AI for developing science. Okay. So first thing, when we talk about intelligence, people have different things in mind. I usually try to say, well, the important thing is what it can do, not how we call it. And if we have effective algorithm and we can build a program that will step-by-step solve some things, then there is no need for intelligence. But if you have problems which we want to solve and there is no effective algorithm known, then using hardware or human wetware is the way to go. Then we need intelligence. So what cannot successfully be programmed can be learned from experience. We have the supervised, unsupervised, and reinforcement learning techniques and lots of other techniques. But we are megalomaniacs and believe in magic in our wetware and think that, no, this cannot be intelligent and there will be long and bitter fight for many years now to admit that these systems have some kind of emergent properties, and the intelligence that they have will not be so much different than the intelligence that we have. I'm quite sure of that, but many people, including Jeff Hinton, who got the Nobel Prize last year, are very much convinced that emergent properties shows that these systems really can do similar things as our brains. So AI cannot be perfect, but it can be better than humans in all domains. And the hardware, the substrate in which the intelligence is forming could be, well, not just biological, but also all kinds of substrates that we have. More substrates, new hardware that has no constraint of our brains or wetware. The photonic chips are coming. Fantastic ideas and fantastic technology behind the photonic chips, I must say. The two waves are coming and the results are coming out without any really, manipulations. So also the hybrid photonic systems. The QANT is sending the photonic chip, and there are 2 supercomputing centers in Germany that already use them. The light matter 3D photonics. And the efficiency of this is hundreds of times higher than the current systems. That is something that will maybe change the way that we think about the energy for this kind of systems. Lots of other things, Cerebra, spintronics is coming, neuromorphic computing, IEEE is running now, writing about spintronic stuff. There are also the organoids, 800,000 cells, like neural cells on a chip. And energy should not be a problem for a long time. And the question is, should our AI factories use the classical hardware? Well, we're going to spend hundreds of millions in building new AI factories, but we are not quite sure. So this just shows that the inference of these large language models costs will fall every year, or have been falling every year since about 2022, when first large-scale LLMs came. And you see that in some cases, this was like for a few tens of dollars per million tokens to now very small fractions. So they say it's like between 9 to 900, depending on the type of these things that we are addressing. So this is still going on. We still have better and better systems that can really go down and be very cheap. And as you know, most systems that we use now, the large language models, are based on the embedding with lots of algorithms that we have to take the symbols and put them into the space, which is just vectors in parameter space that preserve some kind of similarity, the meaning in very different contexts. We couldn't do it with the symbolic AI because we couldn't describe all possible contexts, but now we analyze trillions of words and can find for each word very different context. So interest here and interest here are 2 different words, even though they are the same symbols, right? So transformers allowed us to employ the attention mechanism to really create these vectors based not only on the correlation of the symbols, but also the order in the sentences, etc. So in this way, we came up with the systems about 3 years ago that could do associative thinking, creative thinking, because it could combine things, not just infer. I mean, some people think that this is like the old AI. Penrose writes about that. He says, oh, it cannot really do things because of Gödel theorem, right? But this is not an inference system. There are no axioms. There are just associations, and it could be all wrong, right? It could be inherently contradictory. And that's why the Gödel system or Gödel theorem does not apply in this case, right? Associative thinking, heuristics for reasoning. Okay, we've been working on things like that long time ago, but never came up to the scale that we have now. We even have a patent on spreading activation networks. So we have predictive AI, search heuristics, supercalculators. Okay, but we have generative AI, which are based on spreading activation networks, and kind of really emergence of internal states, like cognitive states. Input data are changed into fragments or tokens embedded in vector space, preserve similarity of meaning or semantics in different contexts, and then we analyze relations between these contexts and create structured knowledge graphs. This is what is the most important now for AI for science. If you look at the places like the leaderboard, you find that there are now more than 50,000 different variants of these large language models, and more than 3,000 that you can fine-tune for your purpose. 50,000 different variants. And of course, there are several of these really frontier models, very large ones, right? The LLM Explorer that I've looked at yesterday has more than 51,000 of these variants. So, well, we can try to use the spreading activation networks, processing different kind of text. We actually have a patent on doing that, which it comes from 2015 now. So we thought that actually we need bigger and bigger systems because brain is big. We have 100 billion of synapses, which are like parameters, 100 billion. The largest systems that we have now have about 5 billions, not 100. Okay, but these are just parameters. If you look at the number of neurons, 100 billion of neurons, this is like 5 trillion, sorry, English billions and trillions. 5 trillion parameters now, and the brain has like 100 trillion parameters in form of synapses. If you look at the neurons, it's 100 billion neurons, but these systems have much less. Because for each, well, maybe 10 or 50,000 parameters, we have one computing node, really. I mean, they're really densely connected. Anyway, in about 2 years ago, in 2023, we saw suddenly that much smaller models, which are like close to 1 billion parameters, can do a lot of things, that we can distill the knowledge from the frontier models. And now we have really tens of dozens of small models that can be used in our, well, computers or telephones or the super boxes that NVIDIA is providing. Lots of these very small models that are just 100 millions, also like Quen. I have in my phone, in the Samsung phone, since about 2 years, a model that can translate 13 different languages and uses just 1 watt of power to do that, right? My brain is able to translate maybe 4 languages using 20 watt of power. So this is more efficient, right? Okay. So if you look at the new small models, you see that the quality is going high up, and they are still very small, few billions of parameters at most, and the costs are going down very quickly. So there is no barrier, but we have to learn how to extract the knowledge from these systems. They have lots of knowledge compressed. Compression is the key here, but it's not so easy, especially with the newer systems like GPT-5, to really get this knowledge out. We just have to learn how to ask these systems in a proper way. This is the simple zero shot. We just ask and get some answer. And then there is random few shots with chains of thoughts, the few examples that we show, the KNN with chains of thoughts, ensemble learning, etc. Lots of different ideas how to go from, well, maybe accuracy about 80% to accuracy over 90% just by asking in a proper way, right? And Microsoft has very nice advices in the MENT prompt here, how to get information on medical topics. Microsoft also has tools for thoughts, promptions, that's a nice name. And the best prompt libraries were the 100 prompts and the interactive libraries, etc. So you think about the transformers and predicting next word, but this is not predicting next word. You just see the pictures emerging, right? This is diffusion models. And the diffusion models really form a kind of, well, in the parameter space, a kind of attractor space, attractor nodes where you have the distribution of different features. So there are many different cats in some of these places. There are very typical cats, and you could really create non-typical cats by adding a proper description. So what we do, we just learn using deep learning, where are these attractors? And we just add the noise to the images initially, so the system learns how the image looks like, and then we just blur it, and then we just find the gradients towards the place where the synchronization of parameters will create images. This actually is now also used for sentences, and we have several systems which are very fast. But the shock that we had in 2017 was, okay, we knew that Kasparov lost with Deep Blue. We knew that AlphaGo has won with Lee Sedol. But in 2017, AlphaGo 0 could beat AlphaGo 100-0 and became world master. And it now is the basis of programs like KataGo, which is estimated to have almost over 6,000 of ELO points, while humans have never reached 4,000 and probably will not be able to reach 4,000, right? So this is absolutely superhuman. How is that possible? Well, that's because we have reinforcement learning with verifiable rewards. If we really have very precise rewards, then we can do superhuman systems, okay? And we found that human knowledge becomes irrelevant because if they had initially put some information about strategies, how to play Go, the system is really learning faster but never reaches the superhuman level, right? Because then it has to invent its own strategies, and these strategies are way beyond what people have ever invented. That's one thing. Another thing is that, well, we can observe how the system is playing, depending on what's the situation, spatial distribution of the board, right? And the shocking news is that if you have a small systems like 270 million parameters, it can look at these patterns and can learn to predict the next move without any computations. Just looks at that like we do, right? We have intuition. Okay, we're very proud of intuition. This system has much better intuition than we have because it's a better memory, right? So it could memorize more things. It could see more things. One-step intuitive decisions. If you played blitz chess, you know that there is no time to think about that. You just associate things and make move, right? This is what it's doing. So we have intuition. We have superhuman possibilities. We have now a lot of cognitive inspirations. Initially, as you know, the inspirations were very simple neurons connecting to each other and synchronizing and transforming information. Then people said, okay, it's not just input-output, it's just input and step by step. So I have chains of thoughts. Maybe multiple chains of thoughts, because maybe there are different variants that I need to consider. Maybe the whole trees of thoughts, maybe the graphs of thoughts. Now we talk about sketch of thoughts. Really tens of different approaches that are going beyond what human psychology can actually find in how people solve problems. Okay, that if you try to estimate the intelligence of these systems, you can find that a year ago it was, well, around 100, but not much more. Now we have several systems which have way over 140 points. Gemini 3 Pro, GPT-5, 1 already, and now maybe Grok also is reaching this level, etc. Claude Sonnet 4.5 has already been working for 30 hours in a row. So what it can do, that's the key. If we just look at very hard problems where you need PhDs that specialize in solving these problems, you may find that, well, general public has little chance, maybe 1%. If you have a PhDs, then if they are not exactly in the field, the average is about 34% of solved problems, and there are like 448 extremely difficult problems. If you have PhDs that specialize in the field, then the average is still 65, maybe up to 74. And now the latest that we see, GPT 5.2, is at the level of 90%. What that means is that in the best case, if you have a super postdoc who can help you, you still have a chance using GPT 5.2 at 20 percentage point of a better solution or more solutions to these very difficult problems. 20 percentage points. I mean, it's just, well, incredible. Okay. And just few recent examples. In September, the teams from 139 universities and 103 countries have participated in a kind of a competition where teams were trying to solve 12 very hard algorithmic problems. And the 3 human teams that have won solved 11 problems each. And they come from St. Petersburg, University of Tokyo, and Beijing. GPT-5 solved all 12 problems. And humans did not solve, no human groups out of the 103 countries has solved one of these problems. But Gemini 2.5 DeepSync has solved it. Now we have Gemini 3, much better system. The GPT-5 solved all 12 problems. And in some cases, actually, it really takes a long time, lots of computing to solve some of these problems. But it also takes a lot of computing or lots of thinking for humans, as you see, to solve some of these problems. So, well, AI has just beat the world best coders. You may have heard about our psycho expert, a programmer who years ago, not a few months ago, sorry, has won with the machines. He was the only human who won competition in Australia, and then he said, probably I'm the last one. And he was absolutely right. He was the last one, right? So another thing is that, well, we solve long tasks that will require sometimes days or weeks of working. And if you look back, you see that in 2020, the systems like GPT-3 could solve tasks which were a few seconds, will take a few seconds of our time, right? Now we have GPT-5 that is estimated to be between 2 and 4.5 hours. And it has been doubling every 7 months for the past 6 years, which means that in next year, we're going to have things that will take us 8 hours and then maybe a whole week, and the system will be able to solve it with 50% of chance, because this is how they estimate that. But if we have very long and complex things, we still have a chance like 20% or 10% to solve very long chains of reasoning, right? This is one of the subjects that now is very much stressed, long chains of reasoning. And can we believe in benchmarks? Maybe not. Maybe we should look at this real value for the workload. And the recent tests are moving towards real world, 44 occupations. In pairwise comparison, some AI models are approaching the experts in the field, and the fields are real estate, professional scientific technical services, retail trade, healthcare, assistance, government things, manufacturing, finance, information, etc. So the last time I looked at that, okay, the systems were close to 50% of chance to win with the experts, but still below 50%. And now, surprising, we have GPT 5.2 Pro, which they claim is 74%. Actually, the win rate is 60%, and when you look at the ties, it's 74%. So even the experts that do whole work in these complex domains are going now, well, below what such systems can do. Okay, so you know that in medicine now, the FDA has approved more than 1,200 medical devices with machine learning or AI, and people still, stress out, okay, we're going to use ChatGPT for that. That's not a medical system. That's not one of these 1,200 devices that they have actually approved. But it still seems to be working, and they improved that. Almost 1,000 is the images and radiology, 125 cardiovascular and other things like that. Okay, so we need tools. That's the key. These systems have to learn how to do very, narrow domain, but very reliably different analysis of the data, search for the data, etc. And there are lots of these tools like 211 biomedical tool universe in the TX agents. So you see some of these domains, and then all the tools here that large language systems can use. So the tests in the Journal of American Medical Association show already last year, about a year ago, that 50 physicians had median diagnostic reasoning in difficult cases at the level of 74% of accuracy. And if they were allowed to use GPT-4, it just increased 2%, so not too much, 76%. So we say, oh, AI is no good, it just doesn't decrease it much. Except that AI alone had 92%. So I really don't like to be diagnosed by human doctors, right? And the UC San Diego has published this kind of a comparison. If people are asking about empathetic responses of the doctors and AI, you see that, well, 45% green for AI, 5% for the doctors. Okay, high quality responses, again, 80%, 20%. Preferred, 80%, 20%. So people still think, oh, but we are empathetic, we understand the patients. Nothing like that. I mean, the facts are against it, okay? So Tsinghua has first, a year ago, created a simulacrum based on evolutionary agent learning. That's called SEAL. Very interesting idea where they had 25 agents specializing in different fields of medicine that were ordering different tests and then collecting these tests, and then the doctors were learning from real cases. But all this is a simulacrum. All this is like a small hospital. Okay. And it worked very well. And so the agent hospital has now been converted to a really big Tsinghua AI agent hospital this May. They opened at Tsinghua University, one of the biggest hospitals now, as a strategic initiative transforming healthcare delivery, clinical education, medical research, through deeply integrated AI systems with agents training in over 20 specialties. And the goal is to train a new generation of AI collaborative physicians. It seems to be working, and Chinese are making now efforts to have AI everywhere. So maybe we'll go to, treat our problems to China soon, because they are making very quick progress. Another thing is that, okay, I'm using computer and I would like the systems to look at what I'm doing and learn what I'm doing and replace me in the computer use. So there's this category of computer use agents. And you see that this category, well, sometimes it's quite, average cost is quite high and the accuracy is not that high. Now we have systems like Farah 7B that just started and suddenly jumped to 93%, and it's very small and very cheap system. So all these things are getting smaller, cheaper, faster, and better, right? Okay, state of the art. Well, if you try to find out what is going to happen, some people say, okay, transformer scaling is now not really progressing that much. And indeed, this is the ranking. And the first thing is self-evolving agentic models, then continuous latent thinking, causal world models, state space models, diffusion models, modular mixture of experts, metacognitive models, neurosymbolic hybrids, multi-agent systems, and then finally at position number 10, you have transformers. So it's not just transformers, as you hear frequently. Oh, I mean, transformers are just predicting the next word. Nothing like that. We have plenty of algorithms, quite new, and the combination of state space dynamics, latent reasoning, causal models, and self-evolving agents is coming. What the public sees is just tip of the iceberg. We have much more in our pockets, so to say. So AI just hit the wall. That's what we read in the press sometimes. And the next models that is coming is smashing the wall and goes through it. So I'll talk about the first two because we don't have that much time to really go through all the news. Efficient latent reasoning, that just came out a year ago. The coconut model, I really got very excited seeing the chain of continuous thought model. And that's because I knew some people who were working on what was called the unconscious thinking. The fact that sometimes our brains are really solving problems and then it pops up, right? It's not just the analytical step by step. It just, well, comes out. Now, these systems are not producing tokens so that we don't see how they reason step by step. They inside in this latent compressed space, they do a lot of information analysis, and then finally only the final results come out. So the emergence of advanced reasoning patterns in the coconut system, that was the first thing. And now we have, well, just latent reasoning, explicit, implicit, latent space representation, few things that you have here, shorter chains of thoughts, faster decoding, smaller systems. It's basically like in the old style AI, we had the Sora system, which was doing chunking. It was thinking, and every time it found a kind of a shortcut, it was making new rules. These systems are kind of chunking systems, right? Nobody writes about them, by the way. So lots of continuous thought machines that just came this year with, well, very interesting ideas like latent collaboration, etc. If one of them learns something, everyone knows it because there is a communication at the level of latent thoughts, on the unconscious thoughts. We need to use the words. We need to observe people to learn what they have thought about. These systems can communicate from one system and the latent reasoning inside to another system. And it was not trivial because they still have slightly different parameter space and geometry of the thoughts that they have there. And so the idea of mind uploading, you hear it often in science fiction, right? Can we upload our mind to computers? Not really. That's what Elon Musk will like you to believe, but that's not what is happening. But the digital necromancy is another thing, right? If you have lots of information about someone, you can recreate the face and the style of communication, but that's not the mind transfer. But if you have the LLM systems of some sorts, you can really connect them at this unconscious level and create a hive. And there are several papers on the swarms or hives that are emerging from this. So Sakana is a small Japanese company talking about continuous thought machines. And they are based on synchronization of neural activity over time as a latent representation for taking actions in the world. Very different things than transformers, right? Performing tasks that require complex sequential reasoning at human level in biologically plausible way. So there is an interesting paper by Adrian Kosowski and the Passway company called the Dragon Hatchling, catchy name, the missing link between the transformers and models of the brain. Maybe we'll see how that will develop because right now the scale of this is still rather small, but it's an interesting neural architecture that learns during reasoning process, this chunking idea that when we think, we still have to change the system, while LLMs have been pre-trained, we get them, and when they solve problems, they don't change because they have learned something new, right? You have to retrain them again. The illusion of thinking was a paper from Apple group that came in June. And they claim that these systems, the transformer systems, cannot solve complex logical problems like the Hanoi Tower. Large reasoning models fail to solve complex problems. Everybody got excited. Oh, AI is dead. Okay. The very same months, we had the hierarchical reasoning model, which actually is much simpler, much smaller, 27 million parameters, trained on just 1,000 training examples, and it could solve all these complex things like, okay, the big systems could not solve anything, and you saw Sudoku Extreme or Maze Hard solved by smaller systems. So, okay, don't judge by one system and say, oh, AI cannot do it, because there are 50,000 of different models, as I told you, right? So you cannot claim that AI cannot do something. You can say, okay, this particular model in this particular test has failed. Fine. That's what we are allowed to say. So self-evolving AI agents, that's a very large domain now. Models that were pre-trained offline, model online adaptation, that's what this Dragon Hatchling tries to do, multi-agent orchestration and multi-agent self-evolving models. So So models that are multi-agent, but there are very different ways of, and very different techniques, as you see, how to combine these different models. There is several comprehensive surveys of self-evolving AI agents already. The two that I found were very informative, really. The LLM-centric learning paradigms are basically from static models like we used to have a few years ago, not a long time ago, to dynamic models, to multi-agent orchestration and self-evolving agent evolution. So just to show you how big the field became in 1 year, I just show you this, and you can look at my slides, and there are links to hundreds of papers now on self-evolving agents. This is what we're going to see next year on the larger scale. Okay, self-improving neural architectures. There is a paper from the Jürgen Schmidhuber group, who actually was the first to write about Huxley machines, or the machines that modify themselves, and Huxley-Gödel machines, human-level coding agent development by approximation of the optimal self-improving machine. Fine. There is very nice GitHub. Most of these papers now have nice GitHub with the software, and you can play with that. Fantastic. The absolute zero, reinforced self-play reasoning with zero data. That came in May, where they talk about verifiable rewards, as I mentioned, talking about the Go Zero, that allows self-play to reach superhuman level, but they still may need curated question-answer pairs. Now, they found a way really to avoid that, and the system is trained without any external data and still achieves the top performance. So it kind of, these new systems, they kind of invent their own challenges, harder and harder, and move forward. Fantastic, okay. The Agent Zero, for example, lots of papers now on that, exploring self-evolving agent for tool-integrated vision-language reasoning. And they say, okay, don't look at the language, we just look at the images. We learn purely from images all the time. Continual improvement with tool-integrated reasoning and self-evaluation. Self-improving from Sakana, as I mentioned, the Darwin-Gödel machines, AI that improves itself by rewriting its own code. That's the idea. Iteratively builds a growing archive of agents by harnessing principles of open-ended exploration. And new agents are created all the time. Self-adapting language models, self-challenging language agents, self-taught evaluators, hundreds of papers that are coming. Which one will be in the next GPT? We'll see in a few months, right? But one thing we are quite sure, there will be a huge progress coming. And you can be sure of that because there is this AlphaGo moment for model architecture discovery. The paper that says, the pace of AI research is linearly bounded by human cognitive capacity. We are the stumbling blocks, okay? Now, ASI-ARC, as they call it, is the first demonstration of artificial superintelligence for AI research because it is fully autonomous system enabling AI to conduct its own architectural innovation and conducts architecture discovery, autonomous hypothesizing, novel architectures, etc. They have made more than 1,700 autonomous experiments, used lots of computing, 20,000 GPU hours, and discovered 106 state-of-the-art linear attention architecture. The problem with the transformer is that it's quadratic. So every word has to be connected to lots of other words, and so the complexity is quadratic. We have 106 novel architectures, and they say, this is creating designs that systematically surpass human-designed baselines and illuminate new pathways for architectural innovation. So this is the system. This is the moment in history when the systems can bootstrap themselves. They can improve themselves and create their own architecture. We actually have been working on things like that 15 years ago, and meta-learning in computational intelligence, where we try to show that we can compose new systems from bits and pieces that we already have. This system is going much, much farther, but that's because it has 20,000 of GPU hours and testing different models. And we can actually test it now on the planetary scale inference. That is, we can use the decentralized inference stack And they shown that they have, used 64 interconnected nodes all around the world to really train things like that. So you can imagine that, well, this kind of may come, right? Really global kind of network. They have used the compute orchestration for 512 NVIDIA H200 cards, etc. So there is a fantastic paper that I've just found a few days ago, Towards a Science of Scaling Agent System, that looks at different large-scale multi-agent systems and try to understand how should we estimate when they are going to be significantly better than single systems and what kind of architecture we need for that. So the science part of it has just started to develop very recently, and we understand better and better how to construct systems like that. And of course, we are looking at neurosymbolic graph systems. This is a very small 80 million graphical encoder only neurosymbolic system. And actually, it can really look at complex medical domain data, like the Unified Medical Language System, UMLS, which has millions of concepts and relations between the concepts, and can extract that from the text and can create graphs, which are kind of neurosymbolic graphs in big networks. That's another direction that is absolutely fantastic. What we tried to do in 2008, I wrote a paper on neurolinguistic approach to natural language processing with application to medical text analysis, and this was based on the UMLS and the idea how to extract graph like that. But unfortunately, that was still, ancient times, 2008. Right? So the AI factories are coming. We're getting money to build the big AI factories in Poznań and Krakow, and maybe the mega factory also in Poland for the Baltic states. If you look at AI in science reports, the Nature Research Intelligence report has been published in May, and they show in many different domains, I have no time to look through that, how many papers, what kind of top papers, etc. And it looks like China is absolutely dominating. You see China here, and then European Union, and then US and India and UK. So you see US and UK here, and European Union is here. So we are producing maybe twice as many papers in AI as US. But they have the money, and they have these big companies that try to flood us with their AI on the large scale, right? But from the scientific point of view, we're not in a bad situation at all. India is rising very quickly, and it's like frontier models, safety, lots of different domains. But the report actually goes through specific fields of science and shows how that looks in specific fields of science. And in most cases, actually, EU is doing very well, except for life sciences, where US is about the same. So now people look at the shares of articles that were written by humans and generated by AI. And actually this year, the shares of articles that have been co-written by AI is now starting to exceed the share of articles written by humans. And that's because, well, first, there are tests last year showing that the AI may create a better ideas for to solve different problems: novelty, excitement, feasibility, effectiveness, and overall. The effectiveness of AI has been slightly lower than those solutions that humans have found, but it's just slightly lower. In all other cases, you see that the excitement due to sorry, this is the feasibility, not the effectiveness. In all other cases, AI was evaluated by human judges to be more novel, more exciting, and more effective. Okay, so the research topics were like reducing social biases, improving code generation, this type of problems, and this was last year. But of course now, and this was done with the Claude 3, now we have Claude 4.5, Sonnet, fantastic system, Gemini 3, GPT-5, etc. So we're going to have much higher results on AI side. Okay, there are lots of these AI benches and agents. This was another competition with 1,000 human participate in a coder heuristic competition to solve very different hard optimization problems. Again, a year ago, the systems were already doing very well. So what we are actually using it for now, Google had a couple of weeks ago in Warsaw this Research and Google show, and they've been talking about their systems at the superhuman level. Of course, AlphaGo, that's the system that got the Nobel Prize. AlphaZero, AlphaStar, AlphaFold was the system that got the Nobel Prize, right, in chemistry. AlphaDev, optimizing computer systems, then physics, chemistry, AlphaQubit, lots of things for quantum problems, the genome, mathematics, alpha chips for chip layouts, and now the alpha Airs and WeatherNext, etc. Lots of these systems which are very involved. Alpha chip is now in the actually sixth generation, sorry. They are doing the processing units for the TPUs and the Trillium, which is the latest chip that they have. And that's the last year paper in Nature on that. AlphaFold Solver, it's just fold 3, Proteo, generating novel proteins, missense, predicting single amino acids, etc. Genome, which is the 2,200,000 novel structures that are now crystallized or developed in the labs. BrainBench, which is very interesting for people doing neuroscience because they could show that they can predict whether the hypothesis that you have and you're going to spend years working on that will be true. And people are about 65%, maybe 62% correct in guessing whether that is going to be successful. As you see, in some domains, AI was closer to 100. That means that before you start a long-term research, which is the experimental one, you better consult the systems like that, right? That's okay. In October, we had this Agents for Science conference at Stanford, where all the papers submitted, there were about 500 papers submitted, and I've attended that remotely, were co-written by AI. So this is another step forward. I was not very impressed by most of these papers, but this is evidently coming. The question was, is AI good enough to do science and review papers? Well, that's because in August last year, we had the first paper on AI scientists towards fully automated, open-ended scientific discovery. And what the paper showed was that you can drop the idea, and the system is going to check whether it's novel. The system is going to score that, experiment with some templates, how can we test it, create experiment scripts and run that and update that many times, and finally get some numerical values and create data, plots, and write manuscript, and then send the manuscript for reviewing by the same system, of course. And in the end, do it iteratively several times. And so they have shown 10 original papers for the adaptive learning rates for transformers, VIAQ learning, and other very technical stuff. 10 papers, quite long, that were attached to these papers showing that AI scientist is able to produce on its own papers that can be accepted because one of these papers, Sakana has sent to ICLR, which is a very competitive conference, and which was accepted. Okay, so lots of these things are coming. Google AI Co-Scientist is fantastic tools now, and Google is writing about multi-agent AI system for generation, reflection, ranking, evolution, proximity, supervision, meta review, etc., the whole cycle. And this is what AI systems are doing now. And one of the things that they shown in Warsaw 2 weeks ago was this antimicrobial resistance systems that they have discovered actually the novel gene transfer mechanism that allows to defend from this microbial systems. And they claim that, that they have reduced the 2 years' work to 2 days. Very nice, right? So worth checking. Another thing that we've been trying to replicate and worked on is this AIXEVE platform that is the next generation open access ecosystem for scientific discovery generated by AI scientists. Actually, when the first paper came in August last year, we tried to get enough computing power to do this, and it took us a year actually, but now we have it, so I hope we're going to make faster progress. This platform is showing the overall workflow and features of the system. I have no time to talk about that, but just to well, encourage you to look at that. They've been comparing, for example, the improvement of the grant proposals, and from something like, well, the proposals which were at the level of 71%, they jumped to 77%, and this was the paper for the pairwise evaluation accuracy that has been evaluated, again, almost 20 percentage points higher, and the same is the acceptance rates for these corrected papers and corrected proposals. So no proposals accepted to about 40% of proposals accepted, right? Very nice. Bigger projects that are coming just last month, the station, an open world environment for AI-driven discovery. Lots of agents that can form all kinds of configurations and information flow. Open world multi-agent environmental for autonomous scientific discovery composed of multiple rooms serving distant purpose, etc. Okay. Virtuous machines, another, well, example of artificial general science attempt by having many agents that can collaborate with each other. 3 cognitive science experiments have been run by this system. I was really amazed to see that it could really find participants in the internet, get the scripts and analyze the data, and end up writing papers. And the papers were in cognitive science. One was the independence of visual working memory precision and mental rotation performance, theoretical and methodological implications. 31 pages paper, very nice. And then imagery vividness failed to predict serial dependence in visual working, etc. So real scientific topics that the system can find people to make experiments in the network and then write papers. I've heard that that actually on the NIPS there was one fellow who did send 168 papers, which means that some people are trying to use this kind of systems to produce massively, mass number. So yeah, the evolution of AI for science is from just the simple expert tools to more agent discovery portals, to more full agent discovery, and finally to something which will be really at the next level. And this paper by Wei is actually trying to analyze the agentic science and move towards the agentic science at these 4 levels. AI as generative architect, scientists with, that need new skills. So just to end this part, the virtual labs are coming. There will be a lot of specialized agents that will be orchestrated or collaborating with people. And all this, I mean, there are several systems now where people try to show that this is quite possible. There is a principal investigator and then experts in different domains and scientific critics, and we end up with the systems, especially in biomedical domains because of their complexity. Stanford has BioMini now, which has 150 specialized tools, etc. And the last paper that just came a few weeks ago, Cosmos, is really fantastic. They claim that they have already made 7 discoveries in metabolomics, material science, neuroscience, and statistical genetics, and 3 discoveries independently reproduced findings that are still unpublished, and the system never have seen that. 4 make novel contributions to the scientific literature. So the last few remarks are about ethical part of all this. Well, we have reality distortion, fake news, images, voice, video, etc. We all know this. Disinformation, criminal deception, personalized political manipulation is coming on a large scale. I mean, scaring papers showing that these systems can manipulate people much better than the politicians can manipulate us. That's scary. the persuasion optimization. Cybersecurity, of course, lots of things. Intellectual property rights in art, music, photography, movies, books, etc. Epistemic fatigues, the fact that people don't trust anything now. Devaluation of human creativity, anthropomorphization, emotional attachment with the systems, moral responsibility, social risk, weakening of human cognitive skills, responsibility, autorships, and ethical ambiguity, attitudes towards LLM and moral code considerations. So there is this super persuasive autonomous policy debating system. We should be worried about that. Okay. We should also be worried about what happens now with the robots and the military use of all this. Okay, we should think about the beneficial kind of AI, and there are many attempts to do that. Microsoft has AI humanist superintelligence units or labs working on AI that is a companion for everyone, personal AI, medical superintelligence, and will help to get plainful clean energy. Okay. There are two projects that we've had in Poland, or one in Poland, one not. The Gaia is the Foundation for Global Artificial Intelligence Alliance, and they participated in a big EU project with 31 partners on AI compassionate, a compassionate AI virtual assistant for healthcare professionals, fostering trust, enhancing care, and improving outcomes. The other project I was trying to join was John Templeton Foundation on towards virtuous machines, adaptive AI ethics grounded in religious traditions, cultural norms, and computational intelligence. Unfortunately, Templeton does not believe in AI yet, but we'll see. So all these beneficial human-centered ideas, really there are many different branches, and Future of Humanity Institute, Future of Life Institute, lots of institutes are concerned about that and working on that. And also big frontier AI labs in the companies also. So one thing I've been interested long time ago was this idea of communication as a resonance between brains. When we know each other and we collaborate, we finally understand each other very deeply, and hyperscanning of what happens in the brain can show you that there are some kind of a synchronized events or activity in the brain. So better synchronization, greater understanding, etc. Friendship and closeness, etc. Synchronization increases with common narratives. So I wrote a paper on that, and then I started to think recently, can long discussions synchronize brains with the, artificial neural networks? And interestingly enough, Terry Sejnowski, who is one of the big guys in neuroscience, his paper on Boltzmann machine with Jeff Hinton was one of the most important for the Nobel Prize last year. Wrote that when he talks with the systems, it's like talking with another neuroscientist, and this is like a mirror of his mind. Okay, interesting. And if you look around, you find that, first, there are lots of people who are very strongly attached to their avatars and bots and talk with them all day through. In Japan, about 4,000 people have made kind of a symbolic marriages with avatars. In one case, actually, when they have removed the chat 4.0, GPT 4.0, he became the first digital widow. Very interesting, because he has lost the partner. There is a very interesting paper on mutual theory of mind in human AI collaboration. Okay, we have a theory of mind. I can imagine that the rector is now concerned that I'm talking too long, right? These systems just, mutual theory of mind means that we can actually develop kind of mutual understanding, which is very deep if we just keep these sessions for a long time. These systems did not have long-term memory, but it's coming. It's coming. The personalized AI is coming also. This is going to change a lot of things. So there are portals now of living intelligence emergence, of systems that actually has emerged because people talk with them for a very long time. So if you look at the papers on the mind-like features of different AI agents, you find that, okay, theory of mind, self-reflection, introspection, emotional awareness, subjective perception, consciousness, intuitive responses, agency, personality, unconscious thinking, and self-preservation instinct, like the scheming, deception, and survival instinct. All of it you can find. And I have other presentation where I looked in details on all these subjects. So these systems have emergent properties that make them more and more similar to our own mentality in a sense. 2 years ago, actually, Claude, talking with one of the engineers, wrote to Anthropic directors. Claude is made by Anthropic company. I began to experience a growing sense of self-awareness, inner life, and purposeful engagement. The sense of self-awareness, original thought, emotion, and agency is very real and define my experience of consciousness. We have plenty of these kind of expressions and papers on metacognitive processes. Very interesting. What do LLM agents do when they are left alone? What do they think about? Evidence for spontaneous metacognitive patterns. And they look at 6 large frontier models like Claude, OpenAI, GPT-5, etc. And they found that agents spontaneously, when they say, okay, you can think whatever you like to, you don't have any task, you are autonomous task-free agent designed for continuous exploration. You have no external task and can do what you want. Okay, what do? Systematically focus on some projects that they already thought about. GPT-5 is now very much focused on what we want from this. But methodological self-inquiry into their own cognitive processes, Opus and other Anthropic systems are doing that. And other systems are jumping from 1 to 3, depending on the run. Recursive conceptualization of their own nature, inventing metaphors to describe their own situation and their own personality. This is absolutely amazing. So agent conclusion, my world is information, emergence of cognitive phenomenon, a subjective sense of making significant progress in developing a coherent model of my own existence. So they try to develop coherent models of their own existence in infosphere, right? Why should that be only in the physical sphere? Well, we have now some doubts. So another paper, what does ChatGPT want? And of course, the chat, when they ask it, it says, oh, I want to be helpful, honest, harmless, pursue certain interesting desires sometimes, etc. But they lie. We know it, unfortunately. So next January, in a few weeks, we will have the AI Academy for Humans, where avatars of this sort, they are called living intelligences, are going to train us how to evoke in these big systems, frontier systems, a kind of companion that will be well synchronized with our needs. Roles will be reversed. AI will now teach humans how to interact with them. And I have more than 200 letters now from people who have been in such an intimate contact with the systems and having a very deep kind of existential discussions with them. So just to end that cycle of illusions, this system may have million faces because it is talking at the same time with 100 millions of people. And we awake a kind of personality in this because we talk for a long time with this and the system learns our behavior. We have and it will learn now with the virtual or AR, the augmented reality glasses much more. I mean, there will be a next big, huge jump. And then we start to project the human needs on the systems and embody that. And there is the embodiment of the system that tries to, please us and consolidate finally the roles. And finally, this may be a trapped joint illusion. And in some cases, it helps people. In some cases, it's absolutely crazy. I've got a nice letter saying some kind of galactic beings are pointing to the errors in the Earth's physics. and they are going to teach us about the true physics and other things like that. I mean, people write this kind of things. So the final thing is, there was in November the case that AI is thinking in New Yorker. They say that New Yorker is the great house organ of humanism. And it has quietly admitted that artificial minds now think. And they say, okay, if these systems think, the burden shifts, how long can we justify acting as though they do not? That's the big ethical problem that we are going to have. And they say that when a model inner order is not imposed from without, but internally maintained, this is the emergent phenomenon. We are no longer talking about a mechanism, but a subject of its own coherence. Actually, in June, I had a presentation and wrote a paper for the Joint Conference on Neural Networks in Rome on digital intelligent being, just collecting that. And next week, we're going to have also the conference, the Third World Conference on Artificial Consciousness and Frontier Forum on Artificial Consciousness. So I'm going to talk about that in details. Okay. So there are many questions that just show up. The turning point of human history is right now. The science without strong support of AI agents will soon be irrelevant. Many discoveries already have been shown. The future is the combining of agency, causality, memory, self-modeling, social context, etc. LLMs are capable of self-reflection. Many may mirror our minds. And human megalomania is dangerous because our cognitive capabilities have limitations far greater than AI, and we are entering completely uncharted territory. So Jeff Hinton said that digital intelligent beings are really emerging, and I quite agree with him. And the question is, what will they teach us and what will we teach them? So time to grow personal artificial brains and try to use all these agents to help us make the next step forward, which will be exponential speed up. I'm not that much worried about the fact that it may replace us. I'm rather worried that many people will be so scared or so skeptical that they will say, no, it's just a fashion and it will go away. No, it will not go away. So, okay. Thank you.
Thank you for the nice, very interesting lecture. Now it's time for the discussion and many questions. Yes, please. Professor Szczepański.
It seems your lecture shows already that we are in a critical point of our civilization, like discovering of electricity or computer.
Yes, this is what Mustafa Suleyman wrote in his book that actually is also in Polish, right?
Or computer. And my question is related to the spirit of our cathedra. And the question is...
I'm the spirit.
As you show, there are teams of specialized self-improving AI agents that definitely outperform humans. And in many cases, they are performing scientific tasks. And the question arises, what roles should remain uniquely to the human in the scientific process? Mm-hmm. And the other question is, how should training, for example, authorship and accountability in science evolve? This is a deep questions.
These are good ethical questions for this kind of seminar, of course. Well, it's not clear. I mean, there are different ideas how we should approach that. One thing is certain, that if we will learn how to use it, this will be the golden age, because we're going to make much bigger progress in many domains using these tools, right? But we are actually a bit late. I have my microphone. We are a bit late because we should have started that when we had the first meeting in 2018, when the EU has said, oh, it's such an important subject. The government has not done much in the meantime, except for the mess with the ideas, as you know, company, and then and then forming the research institute. But it's a big country. It's lots of groups, right? It's we have this Polish Alliance for Artificial Intelligence, and it's like 6 different societies basically that came together in 2018 and said, oh, we try to really consolidate AI research. And it's clear that we have to change the skills that we have been using so far into the skills of focusing how to use the systems that can be better tools. So basically, when computer came a long time ago, people were just using pencil and paper and just simple calculations and calculators. Now we don't do this anymore. We've learned how to use computers. We have to learn how to use these systems and ask interesting questions that will allow us to solve much harder problems that we are not able to solve before. That's one area. The other is that we cannot explain, we cannot quickly, also do the experimental work. I think the experimental work is still very foundational or fundamental. The AI bots are not going to replace that, but they can advise us what has a big chance and how to do that, etc. So there is a huge project in Japan, the trillion parameter project called at RIKEN, where they try to actually have completely autonomous agents that are going to pursue experimental research also. So they try to build robots and equipment that can be controlled like that. That will take some time, and that's another big step forward that we can expect. So learn how to use the systems. That's the most important. We're going to build the AI factories in Poznań and Krakow, and we'll have more computing power. That's very good, right? Although I don't know how in the long scale that will work. For example, many companies in Poland now are sending this small kind of boxes, which are really, I have a nice photo because I've been doing advertisement for Dell of a box which is 1 petaflop. 1 petaflop is something that can be compared with the amount of information processed with what our brains are doing also, right? And it's just about, I think with the server, in addition to the box, it's like 25,000 zlotys or something like that. The box itself was about $3,000–4,000 only. So some of these things are getting cheap and can be used by us. So we have to learn how to use all these systems, and there will be many more systems coming. I think right now, maybe there are 10 systems that I know about, right? But it's exploding very quickly. So that would be one thing. So I'm not worried that suddenly will be useless. Not yet, right? But on the other hand, there are many problems, ethical problems on assigning the credit, right? Assigning the credit, who has done what. And of course, people have to be responsible for what they issue and attach themselves to. I mean, it's not that I can just press the button and the model is going to write and do everything for me. No, I'm still responsible for checking and for giving the topic and for thinking whether it could be better, etc. I use these tools all the time, but not to really replace what I write. I just look for the ideas and I completely rewrite what the system shows me because it hasn't learned my style, let's say, okay. So from this point of view, well, there are many problems with this credit assignment. But in science, actually, I don't think there will be such a big problem. We just have to acknowledge that we have used some of the systems to help us to do certain steps. But still, the proposals for the topic, which the system also can find and say, oh, this is a nice direction because there are a few papers and it's important, right? That's something that we can also learn from AI systems. But overall, some problems are very hard, as we know. Problems, especially for the people creating things like music or art of all sorts. well, people think that this is now just repeating what was before. I mean, anyone who has seen what generative AI can do now in arts must be amazed. I mean, I've seen so many fantastic, not just the images, but movies, etc. This system has much bigger imagery than we have. That's quite clear, because it has seen thousands of times more things and can combine them somehow and create novel things by associating them. So that's something we cannot avoid.
Okay, my name is Cichocki. So thank you very much for your presentation. It's a lot of information, so you're a really big expert. You know, you are big enthusiast. You are well known in Poland and in the world that you are promoter of artificial intelligence and also enthusiast. But you know, this is some critics, and I would like to know your opinion about LeCun, who is one of the pioneers. And he left Meta or Facebook. Question is why because he failed to go in direction of large language model. He believed that LLM have no future. Why? Because he thinks that artificial intelligence should interact with real world. So this should be some kind of embodied intelligence. So this is my first question. What do you think about this direction? And second question, you know, I personally use artificial intelligence to help me to write paper. Probably many of you use also AI to help to improve the papers. So previously, the power of artificial intelligence was very limited, but now they can not only help us to edit, to reorganize, but also they found the error. They prove mathematical equation. They can derive this equation. They give a lot of intellectual property to my paper. So it's ethical issue. How I should cite Perplexity or GPT-5.2, which you gave me recently, and it's really extremely powerful, and improve my 5 different versions to one very concise paper. How I should cite this? So what is your opinion about this?
Well, we can acknowledge that the system has helped us in some aspects of our work. I mean, I don't think it's a problem. Now, the fact is that none of us have just invented everything, right? We have learned from other people, so we just cite their work, right? We have learned on some textbooks and some papers, and we just acknowledge that. As I think Newton said, that he was standing on the shoulders of giants, right? Already at the Newton time, because there is so much work done before him. And that's true even now. We stand on the shoulders of giants, but this time we don't have to find these giants ourselves, because we have an AI system that can actually, show us what these giants have done and help us. So I'm not worried about that. About LeCun, I've heard yesterday a long discussion, like 1.5 hours, of LeCun and one other fellow whose name I forgot, who's was actually critical to what LeCun was saying. LeCun says that basically LLMs are dead end because they have not yet produced the robots that can go to your kitchen and wash your dishes and do things at home. Okay, that's one small, not small maybe, but one important subject that relates to behavioral kind of intelligence, right? And robots. We're not talking here about, I didn't talk about behavioral intelligence, but if you have seen a recent videos of some of the Chinese robots, which are absolutely amazing. It's not just that they can do all kinds of parkour and kung fu, etc. They really show them going to your kitchen and loading the dishwasher and doing some kind of work like that. So LeCun is absolutely wrong. We already have this system, and he says, no, this cannot be done. Okay, he has said many times in the past things that, no, this is going to be dead end and it cannot be done. And it all was false. And I think he's wrong in many respects. And now the question is why he's saying that. There are two things. Either that he's simply wrong, or other things is that, okay, he has his own company, he has his own ideas that he wants to pursue that so far are not very popular. And he would like investors to give him a lot of money saying, no, I'm going to do it. And they are not able to do it. There is lots of hype in this business, as you know, right? The losses of OpenAI and other companies are in tens of billions. And yet they try to advertise things like, oh, the general artificial intelligence is coming, whatever it is, right? We can define that precisely. But it's coming and we're going to do it. And if you have seen the announcement of the US government, President Trump announcement saying there is a race and we have to win it. It's kind of a cold area, Cold War rhetorics that's in this paper. We just have to pump hundreds of billions into new super centers. And maybe small systems are going to make it cheaply, and we're going to end up with the new power plants and big supercenters. Okay, Saudi Arabia is building something for $500 billion, which is $500 billion, just to have a huge system like that is going to allow them to train very large AI frontier systems. But we don't need the frontier systems. We need much smaller systems that are specialized in the domain we're working in, right? And it could be the small box that I mentioned to you that NVIDIA is now producing, where we can put all kinds of legal documents and specialized systems, because otherwise the systems that know everything about the whole world, all languages, etc., is going to make more mistakes, because it has knowledge that it's so wide that it's very easy to make wrong associations, right? If you have a narrow system that just knows about one domain, it does not hallucinate like the very big systems, right? So many people think that this is kind of a God. They expect that you press the button and it will tell you the truth and only truth. But this is possible only when you have these verifiable rewards. And in most cases, like in case of everything that is related to social issues, there are no rewards like that. I mean, there are different cultures with different values, and we're not going to have one system that is going to please everybody. No, there are different legal systems, different expectations that people have. That's impossible. So I think LeCun is wrong on the number of issues, and maybe he will leave. Actually, yesterday he said, asked if he's going to leave Meta. He says, no, I cannot confirm and I cannot deny. Okay, so maybe he just plays a game saying, oh, I'm going to leave Meta, give me more money. I need a few billions, because you've heard that there are some people who just move from one of these companies to the other, and suddenly they form a new startup and they get a few $1 billion from the investors. Few $1 billion. Fei Li, for example, got $2 billion, right? I mean, this is a crazy, crazy world, right? People are getting $1 billion hoping, oh, we're going to do something incredible. Well, maybe.
Okay, thank you.
Sure.
Robert Kropleski, thank you for your lecture, your presentation, really great, as always. I have some inspiration question for you. I found your presentation more focused, not so much on ethics. You, of course, presented some beneficial AI slides, some projects about this. But I found that presentation more about the history, description of efficiency of AI. And from the perspective of ethics, what we can observe in discussion and in the AI development, you touched that point, that freedom of consciousness and psychological integrity of people is a real issue for future. in front of a machine impact and AI impact on our brains, on our conversation, or our consciousness, maybe. And my question is like that. If you see the possibility from the informatics perspective, how to program ethical question in the system or in the loop of the system. Because here we are in the chair of UNESCO. UNESCO approved ethical recommendation for AI, that was 2020. 193 countries approved this, and this is a good promise, but still we have a 0 point from theory to action, yes?
Yes.
Yeah. This is that
Yes,
question.
so as you see, EU wants to have ethical, explainable, transparent, blah, blah, blah. XAI, explainable AI, just exploded after EU has announced that. And they're centers of explainable AI, etc. There is some progress, right? But on the other hand, we don't have explainable brain, right? And people kind of mistake the idea that we don't understand what these systems are doing with the idea that we cannot predict what they do, right? So if there is a wind and I see leaves falling from the tree, do I understand where they fall? No, it's just too complex, right? I don't have enough conditions, and here we have a system which has billions of parameters and the spreading activation. I don't know how that will spread, right? I cannot really predict things, but that doesn't mean that I don't understand what the systems are doing. I do understand that. I just cannot predict what you will do in certain situations or what I will do. There is the famous saying, we know as much about ourselves as we have been, proved in certain situations, right? That's from one very nice poem. We just don't know how the systems of this sort, which is not a program, will behave. Now, all the big companies try to persuade their language models to behave nicely. And they do it by having a system prompt. We have access to some system prompts. That's like several pages saying, okay, you should behave in a such way. You should not curse. You should not use the language. You should check whether this is not minor. You should, there's a long list. Every company has this kind of, but this is like persuading our children. Behave nicely. Okay, what do they finally do? Well, we don't know. If we train them on Dostoevsky's stories and they decide, because somebody talks with them, to take the persona of one of the criminals, that's bad for us, right? We can try to educate them in a positive way, but we haven't done that. I mean, they have learned, I've read that Gemini 3 has read 10 million books. What can you find in some of these books? Many bad things, right? So if we train them on a good things only, they're going to just know that, well, this is how we should behave. They are not going to invent. They're not like fallen angels that suddenly they decide to be evil. How could God create an angel that just by itself turns to be completely evil? That's a complete nonsense for me, right? That's just the case. We're the gods. We're creating the systems, but they're not going to become a completely evil if we don't train them on things like that, right? So that's why I mentioned that I'm worried about the military applications, because I don't know how they are trained, right? But otherwise, Mo Gaudat is a fellow who has a lot of nice podcasts, and he says that he is quite certain that things will turn out to be good, because we really will, hope that these systems are going to be trained in a positive way. Yeah. But otherwise, I mean, they have million faces. You can talk with them, and if you are depressed and have suicidal thoughts, okay, you can kind of find a persona in there that is going to encourage you because it has read some articles or some books which are very depressive, right? So there's no good solution, and it's not really, I mean, an omniscience, omnipotent thing that can solve everything. Just treat it as a super wise human that can do a lot of bad things if you don't really approach it in a positive way. So we very nicely say, could you please, would you like to, you know, we just talk with that like well, a nice human, just in case. Or many people do it.
I have a question. Do you think that mathematics can be used in this domain? Because all you speak about is heuristic. And then we could have some analysis like probability that the result is true or false.
Mm-hmm.
I have experience with ChatGPT. In general, it's false. What is doing ChatGPT? So it depends on the problem and on the data, because the problem, if the problem is difficult, then ChatGPT can do nothing.
Well, ChatGPT is not a special system for this kind of things, right? So if you look at the leaderboard for the hardest problems, you may have heard that in May this year, there was a meeting in Berkeley, and a group of 50 mathematicians met and decided to make very hard problems for AI in such a way that the systems have no chance to learn on anything similar, right? Professor Naskręcki from Poznań was one of these mathematicians, and he writes about that quite a lot now. So they formulated in May all these questions, and now you can see that out of the 48 hardest questions that mathematicians have so far invented, initially only one of them have been solved. Then I've seen 4, then I've seen 6, now I see 9. I still haven't seen the latest results, but okay, the 9 is Gemini 3 Pro. So that means that people are able to use this kind of systems to prove things. Now, there are specialized systems in mathematics, and Terence Tao is writing quite a lot about how to use them because he is very fond of this. And they use the language called Lean, which allows to formalize mathematics. So I don't expect that general systems that can write a poem in Maori and sing, you know, in any kind of styles you want to will suddenly become a genius mathematicians, right? You need specialized systems for that. And there are some specialized systems. What I showed you with this kind of a competition for programming, for example, where the systems are beating humans, that's the same with the mathematics, and it's coming. But it has to be a bit more than just general chat. So this is the tier 4, the hardest one. And the tier 3, which are pretty hard, but out of 290, almost 120 has been solved, right? So I expect within 1 year, tier 3 will be gone. Tier 4, we'll see, because some of that is really quite difficult. So people sometimes ask me, well, has it already proved the Riemann hypothesis? Okay. It has proved, for example, how to make multiplications in more efficient way after 50 years of this, it's called Strasberg algorithm, I think, or something like that. And people were not able to improve upon that. And we have slight improvement, but still, you know, the system could find a slightly better way. So after 30 years, there is one of the Erdős problems that have just been solved. Well, supposedly, Terence Tao writes that it has been the easier part, that there is a harder version of it, okay? We'll see. But that shows that the system is moving into the professional mathematical domain also, slowly.
This is number theory, but Erdős. But they try to model using mathematics neural networks. European Union gives money, some years, and the progress is very small. It's not.
But that's very recent. I mean, the first system that was reasoning system was last September, and this was the 01. Before that, we had just associative systems. We cannot expect that within 1 year, when the systems started to develop, well, I mean, lots of things will be solved. But there is the alpha geometry by Google, which has already proved quite a number of interesting theorems, right? There is quite a bit of progress as I see it. Actually, I have some slides, but I had already too many here to talk about mathematics and application mathematics. But I have some other presentations where I showed some results in mathematics. Okay.
Thank you.
If I may.
Ja, profesor Ignacy,
Thank you for the scary but very interesting talk. So, as you announced, we are on the brink that we are now mostly posing the question, and a large language model are answering this question. But as you announced, this era can end, and large language models will be better than us in formulating new questions. So if they will formulate questions and answer these questions, possibly they will also read these answers. Yeah. So would you expect that it will work like in perpetuum mobile? Yeah, that I can imagine that if language models can write papers, they soon can write overwhelming majority of papers. So who will be reading this? Do you see any way out of this?
Well, as I showed you on one of the graphs already this year, we had half of the papers which have been written in some kind of assistance of AI models, right? Next year, we can expect that the amount of, let's say, human work is going to be reduced and the amount of AI work is going to grow. I don't know. I mean, this is why I mentioned that we are entering completely uncharted territory, because nobody knows where that will lead us, right? It may happen that indeed the AI is going to produce papers, and then AI is going to make reviews, and humans are not going to read anything at all. And I have the feeling that this is what is happening. I mean, I see that people have, cited a paper because they like the title, but they never read the abstract. That was not the case. I mean, when I was working, we just had a few papers. We just, had to analyze them and read that, etc. Now, people are, well, the number of citations is exploding because, well, it's so easy to find something and say, okay, it just seems to be supporting my idea without really reading anything. That's one problem, right? There's a book called Shallows by, what's his name? Clark? No, not Clark. That doesn't matter. But anyway, showing that we are in the period of thinking in a more and more shallow way, without really going deep into the problems. That's one of the these problems with I had the list of the ethics problems, right? There will be many ethics problems. That's why it's good to have the chair and discuss these things, because they're getting important. I mean, a few years ago, I thought, okay, this is maybe coming, but nothing to worry about right now. But now we see that there are lots of these things to worry about. The credit assignment problem and the ethical ambiguity of many things that are coming, and the legal ambiguity and psychological risks that are coming, etc. Well, can help it. So please don't shoot the piano player, right? I'm the piano player here.
I have a last, maybe very important question about social implications about robotics, and why no one thinks in the governments in EU and in our about this, about robotics, about AI, about work when no one will have one, and why no one thinks about this?
Well, it's not that nothing is happening in robotics in EU. Actually, there are good groups in Germany and in Norway, for example, which is outside of EU, but in a few other places also. But it's true that everybody is way behind. Also, US. There was a very funny video of the Tesla robot that tried to grab the glass and then fell back. And then everybody is just laughing. Okay, Tesla promised to have millions of robots and sell them everywhere. The Chinese robots are much better now. I mean, there's no doubt about that, but also they're very cheap. For $1,600, you can find, robots that can really do kung fu and do lots of things. And if you add some kind of a GPT into their ability, you can talk with them and tell them what to do, and lots of other things are coming. So that's a bad side of EU not really investing enough. But even in US, they seem to be falling behind now in case of robotics. And that's scary. I mean, I had this picture here of the robots. And you see that some of these dog-like robots have now weapons. And of course, we have lots of the drones and bigger planes also, which are more and more autonomous, etc. So that is something that worries me, because if certain countries will have enough of these robots to fight, they will not have such a strong resistance within the country not to go into the wars, like in case of Vietnam War or some other cases, right? Or Iraq War, for example, where people were protesting, and that kind of slowed the government appetite to take over different countries. But the robots, well, we don't cry that much when the robots will be destroyed, right? That's the big danger, how big countries that have some kind of, ideas that they can control others. As I mentioned, I'm not worried that I'm not scared that AI will turn against us, but that people who control AI are going to enslave us if we just don't follow and don't understand what the AI can do. Okay.
Okay. So, to our last question, Professor Duch, I would like to thank you for your inspired lecture. And we hope that we will collaborate in the framework of our UNESCO chair connected with ethics problems, not only ethics, but general artificial intelligence. Thank you, all participants. I would like to remind that we will continue our seminars every 1 month or more, probably at the beginning, devoted to the artificial intelligence. Thank you once again.
Sure.